okay to erase this? Okay, let's talk about the symmetry elements then. We're not going to talk about all of them because that's what inorganic is for, but we're going to talk about the ones that are important, or if you take a point group class, I don't know where you would take it in the physics curriculum. I took a course called mathematical physics where we defined all the different space groups and point groups. That was a fun class. That's where I started to actually like calculus. So let's go through, let's talk about each of the symmetry operations. We're going to go over some of the easier ones first. We'll talk about visually what they look like, and then we'll conduct a matrix representation of these. Okay. Symmetry operation identity, it's given the symbol E. Lily, do you remember what this one is? If not, that's okay. This one seems completely stupid to even have, but we need to have it. When it comes to mathematics, there are certain systems, depending on their coordinate system, that this does not follow. What we do for this operation, we want there to be symmetry, we rotate the object 360 degrees. I take water, I rotate it 360 degrees. We'll call this HA, and this one HB. I rotate it. What happens? It looks the exact same. That is stupid, but it is a form of symmetry. Yes. Because every object does have that, and we have, like, that's what it is too. It's really a mathematical formalism. I'm sure Mike down the hall has some sort of bone to pick with that, where it's like, that's not exactly true if you look at non-Euclidean space or some stupid thing in Hilbert space. I don't know. Yes, exactly. In the world of semi-make-believe where I'm at, this is always followed. Okay. Now, the E, I always get a question of where the E comes from. The German word. Anybody know what that means in English? I don't want to even say it because I feel like I'm Einheitsoperator? Is that how you would say that? Okay. What it stands for is unitary operator. Yeah.
He wants nothing to do with this course.
I know. I keep trying to get him to come upstairs too. Oh, he does.
He has 1 extra hour a day. Yeah.
He's a sprinter. He's got plenty of time. It's the distance people that have to go through. The Schon's-Fly symbol is that E. So there are 2 different types of symbols that are utilized. The HM, which is the more common one for crystals. And space groups is 1, just the number 1. Let's look at this as a matrix transformation, and then we'll be done for the day. Okay, so generally we have our matrix operator and we have our coordinates. X, Y, Z, and they get transformed into a new set of coordinates. What is this one going to look like? So remember, we got X, Y, Z along the diagonal. Then we have different combinations of those coordinates. So if nothing changes and we have to have a 3 by 3 matrix, what is this going to look like? Yep, X. So what's the value of X going to be? 1. Here? Yep. What about here? Because as we apply that matrix, what's going to happen? What will we get as a result? Yes, nothing has changed. Okay. In the next set of symmetry operations that we're going to look at, this will change, and something will actually happen with the symmetry. Okay? Are there any questions right now about this? Yep. Yeah, you don't actually have to conduct the operation, but it is important to know what the matrix looks like. Are there any questions? Too many? You can ask. I'm sure if you have it, lots of others do. About yeah, we'll learn everything. We'll learn everything this week about everything we just covered. So a lot of times in class it will be that way, especially for the first part. The middle part is going to be more continuous, which is nice, but we have to be able to talk about how the molecules look first. Okay. Any questions right now? Besides all of them. All right, have a good day.